So first, let's take a look at the series over here. We have this series 1 plus x squared plus x cubed, etc. This is one example of a power series. Let's just look at each individual term. They involve powers of x. Those are power of x, right? This is x to the n power. This is one example of a power series. Now, this power series is a little bit special. Now, notice from one term to the next one is always multiplied by x. So, in other words, that means x here is a common ratio, right? So, the common ratio is going to be x. Okay, from one term to the next is x. Okay. So, this is what kind of series if you have a common ratio? It's geometric series. Yes, you got it. So, that is a geometric series. Now, we know that geometric series is going to converge if and only if the absolute value of the common ratio satisfy what condition? It's less than 1. Yes. So, geometric power series over here is going to converge if the absolute value of x is less than 1. The absolute value of the common ratio is less than 1. So, absolute value of this x here is less than 1, we know that this series here is going to converge. For example, if you have, say, x here to be, say, 0.7, okay? So now then you will have 1 plus 0.7 plus 0.7 squared, etc. And that is going to converge, okay, when it's less than 1. Okay, and we actually know what does it converge to, right? For geometric series, we know if it converge and what does it converge to. Do you remember what does it converge to? A over 1 minus R. The A here is better to remember that as the first term. Yeah, you got it. So it's just the first term over 1 minus the common ratio. Right here. Okay, so it converts to that. So it converts to this. So the geometric series here, if the absolute value of the common ratio is less than 1, it converts to first term over 1 minus the common ratio. Now, in this case, what's the first term? First term is 1, yeah. And what's the common ratio? It's x. So what does it convert to? 1 over 1 minus x, right? You got it. So it converts to 1 over 1 minus x. So now this is an important result, and we want to highlight that and put it together. So we know that this power series, which is a geometric power series, it converges even only if the absolute value of x is less than 1. And we know that it converts to 1 over 1 minus x. So suppose x is between -1 and 1, then it's actually equal to 1 over 1 minus x. Okay, so you got a taste of this power series. Okay, we have a very simple power series, that one. Now, what are power series in general? Here is a general form of a power series. Every term over here will consist of a coefficient. Let's call that C0, C1, C2, etc. Those are the coefficients. And then x minus a to the n power. Those are the power of x minus a. A here is a constant. For example, x minus 2 to the n power. So those are power of x minus a. So this is a power series. Okay? A power series will be in this form. Notice that when the n over here, the index actually starts from 0. When n equals 0, x minus a to the 0 power, we will consider that equal to 1. Okay, so we have a convention over here. X minus a to the 0 power, we will say that that's equal to 1. That's equal to 1. Okay, even when x equal to a. Okay, so the first term will be c0 c0 times 1. So you get c0 over here. Okay, so because of this convention, so the first term n equal to 0, you will get c0. Okay. All right, now this is called a power series. We have different name for this. We call this power series in x minus a. Another name for this is called power series center at a. Now, mine is called the center at a. We're going to know why later on. The center of the power series a, this a here, that x subtracted. Okay. And then also call that power series about a. Okay, about this a. So those are different names to call this series. We have a couple with mark here. Okay, this is the first convention, and the second convention over here. Oh, not convention. A second with mark over here is when x equal to a. What does this power series equal to? What happens if you substitute x by a? What happens? What happens with take x here by a? What happens to this? You get 0. All this that has x minus a as a factor will become 0, right? Which term here survive? Which term is remain? So everyone you have x minus a, when x equal to a, that is going to become 0, right? So all 0, and only which one survive? C0 survive, okay? Only the first term survive, C0. So then the series here is going to be equal to 1. I thought it was going to be right always 1 or 2. It's going to be C0, okay? It's going to be equal to C0, okay? All right, so that's equal to C0. Okay. Okay, so all of this term here is going to become 0, okay? Except that when x equal to a, this is 0, 0, 0, etc. And then this one only this one back. So that's equal to c. Okay, which is a finite number, right? So all the power series, okay, it's going to converge at its center a, because what does it mean? When you substitute x over a, then that will always equal to the finite number, which is equal to c0, right? So it's converge to c0. Okay, so all power series is going to converge as the center. So which means when you substitute center, which is a in it, and always equal to a finite number, which is this c0 over here. Okay, so every power series is going to equal to this finite number c0 when substitute x equal to a. Okay. Okay. Now let's get some example so that we can feel a little bit more comfortable with this. Okay. This example here, we ask, for what values of x is this series here convergent? Right. Now this one here, is it a power series? It is, because the x to the n power, okay? So here it is a power series, okay? What's the center of this power series? This is the same as x minus what? 0, right? And then to the n power, right? So the center over here, the center is 0 in this case, right? Okay. So we want to find out what value x is this series convergent. So what does it mean? That means if you substitute x here by what kind of number, then this series here equal to a finite number. So that's what it means. Okay. Now, how do we find out? Well, first of all, do you think this power series is going to converge at the center 0? If we substitute 0 in x, would that be equal to a finite number? Yes or no? Yes, because we just talked about this, right? All power series will converge at the center and actually converge to C naught. Okay, so guarantee that, right? So first of all, this series is going to converge at the center 0. Substitute 0 there, that is equal to a finite number. Okay. Now besides 0, what else? What other value x is the series converge? Now to find out that, always use the ratio test. So remember last time we talked about when the series here involve a number to the n power or n factorial, then you use the ratio test, right? This is x here to the n power, okay? So almost 99% of the time, right? You're going to use the ratio test. Okay? Maybe sometimes a retest, okay? So ratio test is the test to go for power series like this. Yeah, it's recording. Okay, so we're going to use the ratio test to find out what value x is this series here converge. Okay, let's last time we talked about ratio test, right? So we're going to let an equal to what? What's an in this case? Yeah, you got it. N factorial times x to the n. This is an. Okay, so that is. And then an plus 1 will be, we place n here by n plus 1. Okay, so you got this one. That's an plus 1. Okay. Now, pay attention when you do n plus 1 factorial, you do need to have this parenthesis over here, okay? Parenthesis factorial. Without the parenthesis, it seems like the factorial only go with the 1, okay? N plus 1 factorial, it should be parenthesis and then factorial, okay? Now, the ratio test says that we're going to look at the ratio of an plus 1 over an, and the absolute value of that, okay? Let's do the math, okay? So an plus 1 is this one, so we're going to put it over here. Okay, oh, okay, no. Let's do it together, okay? So we're going to, I'm going to just write it, okay? So I'm going to have n plus 1 factorial, and then to the n plus 1 power, okay? And then, oh, I forgot this. Wait, oh, gee. Oh, when I type that, when I try to convert to map type, he forgot the x, okay? Okay, no. So this one here should be x. Okay, so that should be x to the n plus 1 power. Okay, all right. So this should be, no wonder you guys look confused. Okay. Angela, he say, I got you. Okay. You have the time, you make mistakes sometimes too. Yeah, me too. I make mistakes sometimes. Okay. N plus 1 factorial and then times x to the n plus 1 power. Yeah, you got that was an plus 1. Okay. And then an will be n factorial. So times x to the n. Okay. Now it's better. They feel better. Now let's see what get canceled. Okay, let's do the canceling. So what do we have over here? X to the n plus 1 over xn. We got what? X. Yeah, you got it. Okay. What about n plus 1 factorial over n factorial? What do you get? N plus 1. Yes, you got it. N plus 1. Okay. So over here you should get n plus 1, right? Now the x over here, you put it inside the absolute value. How come you can take this n plus 1 outside the absolute value over here? Because n plus 1 is always positive, right? So you can actually pick out the of this absolute value over here. But the x over here, we don't know is positive or negative. So we have to keep that inside the absolute value there. Okay. So only take out the factor that is positive outside the absolute value. And the part that is not sure is positive or negative, you want to keep them inside this absolute value sign here. Okay. Now, the ratio test says that we want to let n go to infinity and see what happened to this ratio. When n go to infinity, what happened to n plus 1? It goes to infinity. Yes, you got it. Okay. So that goes to infinity. Now, what happens if you multiply with absolute value x? Notice that, remember, for each given x, this is fixed, right? Okay, this is fixed. So when you times infinity, what does this go to? Infinity, yeah. So that is going to go to infinity, right? That go to infinity. So the ratio test says that if the limit of this absolute value of this ratio go to infinity, what can we say about the series? It diverges. Yes. Okay. I actually put it down right here to remind you of the ratio test, right? So the ratio test has 3 parts, right? So if that limit is less than 1, then the series converge up to the b. If it goes to infinity, or it goes to a final number greater than 1, the series diverges. And if it's equal to 1, it's inconclusive. And we have to use other tests, right? So this one here, it go to infinity. So that will be the second case here. So the series is going to diverge. So this is for x is not equal to 0. Okay, for x that's not equal to 0, which is not at the center. So when x equals 0, you cannot divide by 0, right? But at the center, the series converge. Remember, every power series is going to converge at its center. The only place that this series converge will be at the center only. That's the only place. So the answer over here is the series only converge at its center, which is when x equal to 0. Other than the center, it's going to diverge. So what does it mean? That means you pick any number other than 0, for example, like 0.5, 0.7, etc. Okay, any number, put it into the series. Replace x here by that number. That is going to diverge. Okay, that series is going to diverge. So only when you replace x here by 0, this is going to equal to finite number. For other x, they're going to diverge. That means it doesn't equal to a finite number. Okay, so this is a series that is an example that only converge at the center. Okay, right here. Okay, 2 convention here. 0 factorial, turn out that we define that to be 1. Okay, you might kind of feel weird. We have nothing and then okay, become 1. Okay, so 0 factorial is equal to 1. Actually look at my video. Why 0 factorial equal 1? Okay, it's a convention. Also, 0 to the 0 power is equal to 1. Okay, it's also another convention for power series. Okay, for power series, we're going to adopt this 2 convention here. Okay. Okay, now let's look at this example. Now, for what value of x does this series converge? So this, again, is a power series. The center over here is 3. This is the number that you subtract from x. That's the center. So x minus 3 to the n. Okay. So remember, every power series converges at center. So we know that power series converge at 3. Okay. Now we're trying to find for what value of x does this series converge. Okay. We're going to use, remember, the ratio test. Right? So we're going to use ratio test of power series. Every time we try to find what value x does this series converge. Okay. So what does an equal to in this case? Yes, this here is an, right? Yeah, you got it. Okay. All right. So what's an plus 1 over an? So an plus 1 will be x minus 3 to the n plus 1 over n plus 1. So that's an plus 1. Divide by an is the same as multiply by its reciprocal. So multiply by the reciprocal of that will be n on top, right? And then x minus 3 to the n power down here. Okay. So this is the reciprocal of this an. Okay. Now we're going to try to do some canceling. So what are the canceling you can do? These two cancel. What do you get? X minus 3. Yeah, you got it. Okay. All right. These two don't cancel. But this over this, we can actually take it outside of this absolute value because it is positive. So let's do that. Okay. So we take it outside the absolute value when we're sure that it's positive. Okay. And then we're going to keep this x minus 3 inside this absolute value right there because we're not sure it's positive or negative. It could be negative, right? For different x. Okay. So it's important to keep it inside this absolute value over here. Now let's think about what happens when n goes to infinity. Yeah, 1. Yeah, that goes to 1. Yeah, you got it. Okay. This part here is not going to change. Okay. It stays as itself. Okay. As n goes to infinity. Okay. So it stays the same. Okay. So this whole quantity is going to equal to the absolute value of x minus 3. You agree? Okay. I like it. Okay. Remember the ratio test, right? The ratio test says that if the limit here is less than 1, then what happens? The zero converge and converge absolutely, right? Yeah. So it converge absolutely. If this limit over here is greater than 1, what happens? The series diverges, yes. And if it's equal to 1,
3 more tests.
yeah, and no conclusion. You have to use other tests, right? So remember, this is the limit of an plus 1 over an and the absolute value of that, right? So we want to investigate on this. Okay. The way that you can try to think about this, the easier way is to solve this equal to 1 and to find out what x is equal to first. Okay. So I'm going to set this equal to 1 and solve for x. If I set this equal to 1, what does x minus 3 equal to? 1. How can you get absolute value of that equal 1? That means this inside here has to be what number? 1 or negative 1, right? So right here, so this inside over here, it could be positive 1, could also be negative 1, right? Both of them will have absolute value to be equal to 1, right? Okay. So x minus 3 will be equal to plus or minus 1. So what does x equal to? 2 or 4? Yes, you got it. Okay. Okay, so that will be 2 or 4. Okay, you got it. Okay, so on the number 9, I'm going to draw this two number, right? 2 and 4. Okay. But notice that when x equal to this and this, 2 and 4, we have no conclusion because L is equal to 1, right? Okay. Now, we have 2 and 4 over here. The absolute value of this is less than 1, then it's going to correspond to the inside of this interval from 2 and 4. This is 2 and this is 4. this is going to correspond to the inside I here. So x is greater than what? Less than what? Greater than 2, right? And less than 4. Yes. So this inequality will correspond to x is greater than 2, less than 4. It's going to be between 2 and 4 right here. Okay. All right. What about this one here? If it's greater than 1, that will correspond to what? The outside, the part that's further away from the origin. Okay. Correspond to this part here and this part. Okay. So when x is, if it's on this side, then when x is what? Less than 2, okay. Less than 2, okay. All right, when x is less than 2. So on the left side of this 2, right? So that was x is less than 2. Yes, okay, got it. Okay, or x is what? Greater than 4 on the right side of 4, right? So greater than 4 here, okay. All right. So now let's put them together and look at the big picture, okay? So next time if you see something like this, you will set that equal to 1, and then you find the two number, right here. And then you know that the inside over here, right, this right here, it's going to be converge absolutely. And then the outside right here is going to be divergent. The series is going to diverge. Okay. All right. But we don't know the end though. This 2n, 2 and 4. Now for the 2n, you need to test them. Remember, we need to use, because there's no conclusion for ratio test, we have to use other tests. So the way that you test it, you can just substitute. Okay. Substitute the x equal to 2 or 4 into that power series, and then see what happened. Use other tests. Okay, what happens if you substitute 2? If we put this 2 in here, what do you get? -1 to the n. Yes, you got it. Okay, so that's -1 to the n. I think I get too much information. But anyway, so you see that it's going to be -1 to the n, right? And then times 1 over n. This series over here, notice that what happened without this alternating sign, right? This is the alternating sign, right? Okay. And then 1 over n. Without alternating sign will be the harmonic series. And now with the alternating sign, it's an alternating harmonic series. Converge or diverge? Converge. Okay. And the reason for that, remember we talked about that, is by the alternating series. Okay. Every alternating P series is going to converge. Okay. This one here is the P series. Now with the alternating sign, it's going to converge by alternating series. So remember this result. Every alternating P series here converge, okay, by alternating series type. So that one converge, okay. This is an alternating harmonic series, okay, converges. All right, so that's what we mean, say, use other tests. In this one here, we actually use, so we substitute in it, we actually use this alternating series type, and to conclude that this one here converge. Okay, so the ratio test has no conclusion. However, we use the alternating series test here. We see that when x equal to 2, this series here converge. Okay, let's substitute the other n. Okay, remember we need to test the 2n. So when x equal to 4, substitute 4 in here. What do you get? 1 over n? Yeah. So that's 1 over n, which is a harmonic series. So converge or diverge? It diverge, right? Yeah, it diverge to infinity, actually. So now we can put the result together. So we know that at 2 over here, it converges. At 4, it diverges. So, and then remember, it's going to converge inside here. Converge absolutely inside. and then diverge outside, right? So the series is going to converge inside here, including this end, but excluding this end, right? So it's going to converge everything inside here, but then this one here we already tested. It's converged. This one we tested and it diverged. So we input this one, exclude this one. So the step that you do here is you first find the two ends. So by setting the L equals 1. And then the inside converge absolutely, outside diverge. Okay. Then you test the two ends. You substitute x equals 2, substitute x equals 4 in it, and then to see if it converge or diverge. If it converge, we include the end. If it diverge, we exclude the end. And then we get a linear answer. Okay. Now, over here, then you write the answer here. So for x in this interval, including 2 and excluding 4, that power series converge. This interval here, we call that interval of convergence. Okay. Now, let's look at the interval over here. So what is the center of this? 3. The center is 3, right? Isn't that this number over here? Right? It's exactly this number. That's the reason that we call that this is a power series center as 3. So when you find the interval convergence, this number here is always in the center of this interval. Okay? So we call this power series center as 3. That's in the center of this interval convergence. Okay? All right. Question. Okay, next one. Okay. For this one, it looks kind of complicated. However, it's actually quite easy to do it. Okay. This is called the Basel. How do you say this word?
I would say vessel.
Bessel? Bessel?
Yeah, not positive.
Okay, Bessel function of order zero. I wonder what language is that.
Vessel.
Bessel? Bessel.
Vessel.
Bessel. Okay. Okay, you guys are expert on this. Better than me. Okay. So Bessel function of order zero. Okay. I think has something to do with the vibration of the drum. Yeah, something like that to model the vibration of the drum also. So this is a function. It's a function of x. So for different x, you're going to get a different number. So this might be the first time you see a function expressed as a power series. Okay, so that it's possible to do that. So we want to find its domain. Okay, what does it mean, domain? Domain is all x such that the series equal to a finite number. The all x here, the series converges. Okay. So remember to do that. To find those x value, we use what kind of test? Ratio test. Yeah. For power series, you use a ratio test to find out what x to make the series converge. Okay. I'm going to let you guys work on this. Use a ratio test. Okay. I'll give you guys 5 minutes. Okay. Does it look like bread to you guys? Drink cranberry juice and okay. So anybody, any volunteer? I think Ryan did a lot, but besides Ryan, who else? Looks like Diego is done. Diego, come on and do it.
Not done.
Huh?
Not done.
You're not done? Okay. All right. Looks like Ike is done. No? Who else? Hey, who wants to raise your hand?
Set it up.
Huh?
I can set it up.
You can set it up? Okay, so you want to go ahead and okay, let's see. How about It looks like so that okay, 伟业. Yeah, I saw you talking to your neighbor. Maybe you're done. Want to try? Give it a try. Okay, let's do it together. Okay. So first of all, so substitute m+1 in it to get x to the a. So am+1 is going to be the an. Am+1 is the number that is, we're going to replace this n by m+1. We have this 2 times m+1. Now what happens here is over remember, let me write down this. Okay. So this is what -1 to the n. Let's take the 2n over t to the 2n and over m factorial and go from 0 to infinity. So this one over here is an. Okay. This one here is an. So an+1 is going to, but because this absolute value over here, so all the things inside over here you can ignore it. Okay? So we can ignore this part right here. Okay. So now we can just replace the m+1 here. Replace n here by m+1. So that's x to the 2 times m+1. And then over 2 to the 2 times m+1. And here you will have the parenthesis of m+1 and then factorial, and then we square that. So this is a of m+1. And I will get to this later. And then divided by an is multiply the reciprocal of this. So this 2 to the 2 m power will go to the numerator, and the m factorial square will go on to the numerator, and x to the 2n will be in the denominator, right? So the alternating side, we can ignore that because the absolute. Now what we need to do here is so we can next time we can ignore the alternating side. It really doesn't matter, okay? Because the absolute value we can ignore that. Okay? So you don't need to worry about that. Okay? And what we do is we distribute this. So it is x to the 2n plus 2. That's good. And then 2 to the, and then we distribute this, and x to the 2n plus 2. Right? And then this is n plus 1 factorial and then square times 2 to the 2n n factorial square, and then x to the 2n. And now let's see what are the cancel. Okay. So you can ignore this alternating side, and we need that matter. Let's erase it to keep that tree. Okay. Now what are the cancel? So you say, okay, now this one and this one, dividing, you have x to the 2n plus 2 on top over x to the 2n. Dividing here, that's equal to x to the second power. Because you subtract exponent, remember? This subtracting this is equal to 2. So you get x to the second power. So this is not, okay? And what about this part right here? This is 2 to the 2n, 2 to the 2n plus 2. Then this is 1 over 2 to the second power. remember you use this exponent, subtract this exponent. You have the 2 here, and this one has more power, so it stays in the denominator. So canceling this, you get 2 to the second power. So that's what we did. And so this 2 cancel, and we get 2 to the second power down here. And then what about this n factorial over n plus 1 factorial? N factorial square over n plus 1 factorial and then square. Isn't this the same as the square of n factorial over n plus 1 factorial? Right? Yeah. Okay. Okay. So because both of them are square, so you can take this outside like this. But what is n factorial over n plus 1 factorial?
N plus 1.
Yeah, it's 1 over n plus 1, right? This one here has one more factor, n plus 1. Okay. So finally, then this is this 1 over n plus 1. Okay, and then you can put the square over here, right? Okay. So the final result here is it's going to be this. So you get x squared in here. Okay, so you can ignore the minus sign, ignore the negative sign. Okay. And x squared on top, 3 to the second down here, n plus 1 squared in the denominator. So that will be 1 over 4 n plus 1 squared, and then over here absolute value of x squared. But do we need the absolute value here in this case, you think? Now it's perfect. Okay. So now it's right. So you did a good job. But next time for those alternating sign, when you take absolute value, you can actually ignore them, okay, to make the computation a little bit simpler. Okay, so here is what I did. I did basically the same what Wei did. Okay, so over here I distribute this 2 in here. So x to the 2n and x to the 2n power and x to the 2n power here cancel. Here distributing the 2 to the 2n power and 2 to the 2n power here cancel, and giving you this 2 to the second power, which is 4. Okay. And then this factorial over this factorial is 1 over n plus 1. And then we have a square over here. Okay. So what I did over here is I simplify this, okay, and do the canceling over here. I come up with this x squared over 4 times n plus 1 square. Okay, because x squared is positive, we don't need the absolute value there. And then remember here, for any fixed x, any given x, x squared is fixed. But then n go to infinity, the denominator go to infinity. So this whole thing go to 0, which is less than 1. By the ratio test, we see that the series is going to converge, and for all x, because for any x, this is going to go to 0. Okay, so for all x. So the series converge for all x. Okay. So what's the interval of converging them? Yeah, it's from infinity to infinity. Yeah, you got it. And that will be the domain of the function. So that means within this, the function is going to equal to a finite number. Okay, that's good. And the radius convergence will be infinity, because see, here's the center, right? And then to the end is infinity. So interval convergence will be from infinity to infinity. Radius convergence will be infinity. Imagine this here, keep on going, right? You keep on going like this. All right, question. I think the part that might give you guys trouble is the algebra, the canceling, those. You just need to practice on this, okay? So remember, use ratio test for power series. Okay, now we come to this theme, okay? We're not going to prove it. It's already proven. So what's this theme? It's kind of important. This says that every power series it's going to fit in one of these possibility. Okay. The first possibility here is the series converge for all x. Do you see this? What is the example for this one? The series converge for all x. Isn't that the one that we just did right here? Right? See this series over here converge for all x. Okay. And the interval convergence will be what? If it converges for all x, interval convergence will be negative infinity to infinity. And what's the radius convergence? Infinity. Yeah. Okay. So that is one possibility. Okay. The last example we just did was this one. Okay. Okay. What is the second possibility? It converges only at its center. Do we see this one? I think the first example we did, right? So that one only converge at the center. How do you write the interval convergence if it's just a single number? You put a braces, insert the parenthesis, okay? So if this is just the meaning of a set that has only a single number. Okay? So braces and put the number. So that's the interval convergence. And the radius of convergence, well, from the center, there's no place to go left and right, right? So the radius of convergence will be 0, okay? So that was the second possibility. So this is going to be converge for all x. This is only converge at the center. What's the last one? The last possibility is the series is going to converge. It's going to converge within this radius convergence from the center, from here to here. And outside of that, it's going to diverge. Okay, so always from the center, go left and go right. Within this radius convergence, then this inside here will converge absolutely. And then the outside here will always diverge. And what happened to the endpoint? Do we know the endpoint? Now the endpoint over here, we don't know by the ratio test. And then what we do here is we're going to test the endpoint. So we just need to substitute and use other tests to test the endpoint. So the interval convergence could be like this, could be all open, because if it doesn't converge here, if it diverge here, and then we won't include that. So it will be parentheses left and right. Hey, great work. Okay, now let's finish this two example together, and then we're done with the day. Last time we talked about there are three possibilities for a power series. What are the three possibilities? Okay, without looking at this, okay, can you tell me what are three possibilities? The series will converge for all x, okay, and then the second one will be converge only at the center. And the third possibility is the series is going to converge within this radius convergence from the center, okay, and then diverge outside. And for the endpoint, you're going to use other tests to test the endpoint to decide that either include that if it's convergent, then you include that, and if it's divergent, you will exclude that end right there. Okay, so three possibilities for the power series. You almost always use ratio test to find the interval convergence and radius convergence. So ratio test is the test to use. Now we're going to do this example. Okay, this one here to find interval convergence and radius convergence. Okay, so what test we use to find I and R? Ratio test. Yes, good. I want you to go ahead and use the ratio test and find out what you have here, and then continue. I'm going to pause the recording and give you 5 minutes to work on this. All right. So remember, we always use ratio test to find the interval convergence and the radius of convergence, right? So we're going to look at the ratio of an plus 1 over an and the absolute value of that. Now, because the absolute value, do I need to worry about the sign? We can actually drop the -1 to the end, right? You can ignore this negative sign right here because the absolute value, okay? So therefore, an plus 1, okay, so we're going to have 3 to the n plus 1, okay? So I just dropped the minus sign because the absolute value of an plus 1 is going to be without the negative sign, okay? And then times x to the n plus 1, right? And then divide by what? Square root of n plus 2. Yes, you got it. Okay, n plus 2. So this is an plus 1. And then the absolute value of this. And then we're going to multiply by the reciprocal of an. Then that way we're going to take this denominator and flip it to the numerator, right? So we're going to have square root of n plus 1 on top, okay? And then down here, what should I put down here? 3 to the n times x to the n. Yeah, you got it. Okay, and then absolute value of this, right? Now let's do the canceling. What happened to 3 to the n plus 1 over 3 to the n? Becomes 3. Yes, you got it. And what happened to x to the n plus 1 over x to the n? It become x. Okay, good. Now, there's nothing else we can cancel. Now let's put this. What about this square the n plus 1 over square the n plus 2? Would that be always positive? Yeah, it's always positive. So we can put it out in front of the absolute value. Okay. And which part here is not positive? Which part here is not necessarily positive? The x. X is the only one that's not necessarily positive. So we're going to keep the x here inside this absolute value there, right? Okay, good. So keep this x here inside this absolute value there. Okay. And then the other part here is always positive. Okay. All right. Now we're going to take as n go to infinity. As n go to infinity, what happened to this? What does it go to? You look at the dominating trend, remember? Right? Yeah. So infinity over infinity. It depends. Okay. So look at the dominating trend. So this is kind of like 3 square root of n, right? 3 square root of n. And down here you have what? Square root of n. Okay. So 3 square root of n over square root of n is what? Is 3. Yeah. So even though both of them go to infinity, but this is always 3 times this. So the ratio is going to 3. Okay. It's not 1. Okay. So that's 3. Okay. So we go to 3. All right. So that's why you got that is going to be 3 times square root of x. Now we're going to set that equal to 1 in order to find the endpoint, right? So this step over here, let's just say it's a step to find endpoint. Remember the endpoint of the intervals, okay? So we're going to set that equal to 1, okay? To solve this, x here is positive or negative 1 over 3, right? You divide both sides by 3, x is, the absolute value of that is equal to 1 over 3. So x is plus or minus 1 over 3, right? Okay. By the ratio test, do you remember that? If this limit, remember this limit right here, right? Okay. So I should continue. When this limit over here is less than 1, then the series is going to converge, right? And converge absolutely. And when it's greater than 1, the series will diverge and it's equal to 1, and then you use other tests, right? So now we got the 2n here, right? We get this n. This is negative 1/3 and positive 1/3. Okay. Now, so we know that within this is going to converge absolutely. Okay. And outside here and here is going to diverge. Okay. But the only thing here is we need to test the endpoint. Okay. So we want to see what happened at this end and this end. So the way we do here is we're going to plug in the number. So if I plug in x equal to negative 1/3, what happened to the series? What does it equal to? Okay, so let's see. If it's negative 1/3, okay, let's put it here. So we're gonna get this. We're gonna get this, right? So you substitute this negative 1/3 in here. X is negative 1/3. So you put it over here. What happened when they have both raised to the n power? Then we can remember this, right? So when you have negative 3 to the n times negative 1/3 to the n, both raised to the n power, then you can put them under the power n, right? So that's equal to negative 3 times negative 1/3, and then raised to the n power. Okay, like that. What's negative 3 times negative 1/3? That's equal to 1, right? That's equal to 1. 1 to the any power is equal to what? 1. Okay, so that's equal to 1. So that's equal to 1 on top, and then square root of n plus 1 down here. Okay, yeah, so you got a 1 right here. So you have 1 right here. Okay, so do you think the series converge or diverge? What's the reason? It's a p series with p equal to what? 1/2. Yes. So this one here diverges. Okay, good. So that's actually is a p series. But if I write it the long way, I substitute the index in it. N equal to 0, I get 1 over square root of 1. N equal to 1 is 1 over square root of 2, etc. Right? So this one here is equal to this. Do you agree? You actually can do a shift of index. Okay? So the index here start from 0. Now you can make the index here start from 1. These two are actually the same. Okay? If you write it the long way, they have the same turn. So it diverges, as you said. Okay? It's a p series, a p equal 1/2, diverges. Okay? So we should exclude this negative 1/3 from the interval. Okay, how about do the 1/3? How about you substitute the 1/3 in it? 1/3. Put it in. What do you get? Yeah, this will be 1/3, right? And except this time when you do the canceling, this 2 will become what? Negative 1, right? So it will become negative 1. So it will be negative 1 to the n power, right? So it's negative 1 to the n power. So the difference between this one here has the alternating sign. Okay, like that, negative 1 to the n power. Converge or diverge? I hear Diana said converge. What's the reason? Using the alternating series test. Yes, you got it. Okay, this is like using alternating series test. Okay, good job. So if I write it the long way, it actually is going to be like this. Okay, so it converges using the alternating series test. Okay, right. So over here, what I have done here is I just do a change of index. So I substitute index n go from 0 to infinity. I can actually change n go from 1 to infinity. And then insert the n here, I will put n minus 1 right here. Okay, so like that. It is an alternating P series, converged by alternating series test, right? Now we can put the result together, right? So we remember last time we said that the possibility is just converge inside and diverge outside, right? And then because this part here at -1/3 it diverges, so we exclude that, right? And at 1/3 it converges, so we include that. So parenthesis here, bracket over here. So what's the interval convergence? What's I? This? Parenthesis or bracket?
Well, it's open.
Open. Yeah, open here. And then this, comma, and then 1/3 bracket. Yes. So that will be the interval convergence. Okay. What about the radius convergence? 1/3. Yes. The center of this is 0. Okay. So the interval convergence is the radial convergence will be from the center to the end. So in this case, it will be 1/3. Yeah, you got it. Okay. All right. Good. Good job, you guys.
It's always the same point on either side.
It's always -1/3. Not necessary. Last time we did that from 2 to 4, right? Did we do some? Okay, let's see. This one over here. You see this one? The one we just did over here is from 2 to 4. Okay, it's not -2 to 2, etc. Okay, but it's going to be on the both sides of the center, equal distance from the center. Okay, so it's going to be like this. The center over here, and then go to the left and go to the right, R. Then it's going to converge from here to here. Okay, depends on the center. Sometimes the center is 0, sometimes the center is not 0. Okay, so like this. Does that answer your question? Okay, good. So in this case, the center is 0, so it's going to go 1/3 on this side, 1/3 on this side. Okay, the next one over here, I also want you to try it. Okay, try it first. Okay, so you did a good job of finding the D2N. Okay, so the first step over here, you found that. Okay, what happened is you do the cancellation. Okay, you did the cancellation, and that turned out to be 1/3 times absolute value of x plus 2. Okay. Okay, so that's the first thing to do. So you got that one. And then the next step over here is you're going to set that equal to 0. You set that equal to 1 to find the endpoint, right? Okay, so and then you got that x equal to -5 or 1. Okay, you got this part here. Okay, good job on that one. And then the next thing here is you know that it's going to converge absolutely from -5 to 1, and then it's going to diverge outside because the possibility says that if you have this and this one, it's going to converge inside and diverge outside. Okay. Then the next step here is to find out what happened at the endpoint. So substitute x equal to 1. Actually, okay. Oh, let's do the -5 first, because -5 is smaller. Okay, so substitute x equal -5. Then what do we get here? So we replace x by -5, we got this series here. And did you just set that is equal to, now -5 plus 2 is -3, right? So this one over here, it is going to be, this is -3. So you have -3 to the n power, right? -3 to the n power. All right. Now, but then down here, what do I have over here? This one, we have this. So over, what happened to this 3 to the n power, n plus 1 power? It's the same as 3 times 3 to the n power. This one to the n power, this one to the n power. We can group them together, right? Okay. So group them together, what do you have? Oh, don't forget there's an n also over here. Okay, that's an n. Okay. So this two together is going to give you what? -1 to the n power, right? This one right here. And then over here you have n, right? This is an n. And then what happened to this 1/3? The 1/3, you can put it in front. Okay, like that. So -3 to the n power over 3 to the n power is -1 to the n power. And then you have the n here, you have the 3 here. We can take the 1/3 in front of the series. And then we have -1 to the n times n. This series over here converge or diverge? What do you think? Diverge? Why? What test? Alternating? Well, alternating series test, don't say the series diverge. Huh? Test for divergence. Yes, test for divergence or entrant test, right? Yeah, you got it. So it diverges because the entrant doesn't go to 0, right? Remember, if the entrant, this is the entrant, it doesn't go to 0. As n go to infinity, definitely doesn't go to 0, right? So by the test for divergence, it diverges. Okay. Yeah, you got it. Okay. Good job. Okay. See, the sign alternate, but then n go to infinity, definitely doesn't go to 0. So the entrant doesn't go to 0, the series diverge. Okay. All right. So then we can exclude -5. What about -1? +1. Yeah. Is it -1 or +1? +1. It should be +1. I think maybe Ryan put a -1 there. Maybe that's the reason that, yeah, it is +1. Okay. So put a +1 there. You're going to get this series here, right? This. So +1 over here, you put a +1 over here. Okay, we place x by +1. Let's simplify this. Okay. So on top, you will get n, okay, times 3 to the n over 3 to the n times 3, right? You get this. And then what happened to this? Can you cancel this two? Yeah, this two cancel. So what's the result? Can we take the 1/3 in front? Yeah, we can take the 1/3 in front. Yeah, and then the series here is 1/3 times the series n, right? Converge or diverge? What test? That's for divergent. The entrant doesn't go to 0, right? So test for divergent, then the series also diverge. Okay, the last step is putting everything together. Okay, so you put everything together. Should we include -5? No. Should we include 1? No, because they diverges, right? On the two end, it diverges. So what's the interval convergence? Yes, you got it. Parenthesis -5, 1, the open interval. What's the radius of convergence? It's 3. I heard that someone say -2. -2 is the center. Yeah, the center is -2, but the radius convergence, it is from the center to the end. It is 3, so that's equal to 3. Okay, all right. So that's all for today, and thank you guys for coming.